Okay, so we've looked at finding slopes before. Here, we're going to find the average rate of change. Let's just go through this and I'll talk about it in a second after I read through it. So it says if A and B, A can't be equal to B, are in the domain of a function y equals f of x, we can say that the average rate of change of f from A to B is defined as, one way to write it, the change of y is that triangle y in the numerator all over the change in your x value. So this is looking at the change of our y value, fb minus f of a, all over the change in our x value, b minus a. Again, a can't be b. So we've been able to find slopes before on a graph of only lines. And what the average rate of change is doing is basically looking at, so let's say maybe we had a graph something like this, and we wanted to find the average rate of change from this value from x equals a to, how about this value, x equals b. And so I know that if x equals a, my y value I can express as f of a. And my y value at x equals b, I can express as s of f of b. So I have these 2 points, right? A f of a and b f of b. So I can find the slope between those 2 lines, or the average rate of change between those 2 points if I find the slope of that line. So f of b minus f of a all over b minus a. And so that's what the average rate of change is. This line that joins those 2 points, that is called the secant line. So there's a theorem. And this is another thing that you'll be doing in calculus. You'll be finding equations of secant lines at the beginning of the course. Some of you have mentioned that you have to take calculus, but you're a little worried about it. But if you get down these and you're really strong with your algebra, you should be fine. So theorem, slope of a secant line, which I just told you. So the average rate of change of a function from a to b, that equals the slope of the secant line containing the 2 points a f of a and b f of b on its graph. Okay, so let's look at an example. Let's say that f of x is equal to negative x cubed plus 1. And we want to find the average rate of change on the interval, let's say negative 1, 3. So we want to find the points. So let's look at what's happening. Let's look at f of negative 1. So if we go back in here and wherever we see an x, we plug in negative 1, we would have negative parentheses. I see an x, so negative 1 quantity cubed plus 1. Well, if I cube negative 1, I get negative 1 times the negative in front, that's positive. So here we would get 1 plus 1, or 2. So we have this point at negative 1, 2. And we want to do the same thing and find the point when x is 3. So going in and plugging in 3 wherever we see an x, we have negative parentheses 3 cubed plus 1. Well, 3 cubed is 27 with a negative in front. So we got negative 27 plus 1, which is negative 26. So we have a point here at 3, negative 26. So we're looking at the change in our y all over the change in our x. So if I look at negative 26 minus 2, and then change in my y, so 3 minus negative 1. So we get negative 28 in the numerator all over 3 plus 1 really, so 4, which is negative 7. So the average rate of change on that interval is negative 7. What if it asked us to find the equation of the secant line? Okay, well, remember we needed two things when we were looking for the equation of a line. We need a slope. Well, we just found the slope. That's going to be negative 7, and we need a point. Well, we found 2 points. The points on that interval. And so it looks like it'd be easier if I use the point negative 1, 2. So we were looking at it where we were plugging things into y equals mx plus b, solving for b, and then rewriting our equation. So if I have y as 2 equals my slope negative 7 times x is negative 1 plus b. So 2 equals 7 plus b. Let's subtract 7 on both sides. So b is negative 5. So the equation of the secant line, it's y equals our slope, negative 7 times x plus b, so minus 5. Okay, so we have h of x in front of us, which is equal to negative 2 times x squared plus x. We want to find the average rate of change from 0 to 3. And we want to find the equation of the secant line, 0 h of 0 and 3 h of 3. Well, we got to find their points. And so we want to look at what is h of 0. So going in and plugging in 0 wherever I see an x, notice that I'm going to get back 0 because I get negative 2 times 0 squared is 0 plus 0 is 0. So I have a point here. This is really 0, 0. And now I want to look at h of 3. So plugging in 3 wherever I see an x, I get this is negative 2 parentheses 3 squared plus 3. Order of operations, square the 3 first, I get 9. 9 times that, negative 2 in front is negative 18 plus 3. So this gives me back negative 15. So I really have a point here. Now the way to write this is 3, negative 15. So to find the average rate of change, I need to look at the change in y all over the change in x. So I have 0 minus a negative 15. All over 0 minus 3. So 15 divided by negative 3 gives us negative 5. So there's our average rate of change. And now it wants us to find the equation of the secant line joining those 2 points. And so we have a 1 point, 0, 0. Actually tells me that has to be my y-intercept has to be 0, right? So actually on my equation of my secant line, y equals my slope, negative 5 times x plus b, which is 0. So my equation of my secant line is y equals negative 5x. Okay, so that is the section on 3.3. So looking at where is our graph increasing, decreasing, constant, finding absolute max, absolute min, local max, local mins, and then looking at this average rate of change and finding the equation of the secant line.